Jorge, Sancha, welcome to Software Engineering Daily.
Hey, Alex. Thanks for having me. It's great to be here.
Yeah, so Jorge, you are the founder of Tinybird, which is a real-time analytics company. Tell us more. What does Tinybird do?
So Tinybird is a platform and a set of tools that speed up and simplify development over huge amounts of data, over data at any scale, really, just using the SQL query language. It helps developers ingest and transform data at any scale, and then it also enables them to build APIs that they can expose and integrate into their product. So you can think of it as a data warehouse for developers, one that they can use as a backend to build and scale APIs over any amount of data. It also works serverless, so it's designed specifically for developers that might not be familiar with infrastructure, such that you don't have to worry about how many servers you need to provision or what's the right configuration for each of them, etc. You just throw data at us, and we take care of helping you scale that up. And essentially, our goal is to enable any developer to build and scale data products and applications over any amount of data, whether that's big or small.
Awesome. I love it. And I want to get more into the architecture and all that stuff later on. But one question I have here is what data size should I have before I start considering Tinybird?
I mean, the beauty of it is it doesn't really matter. This works really well anyway. It's more about what type of data more than the size of the data, and what you want to do with it. So it's great for analytical data is when you want to figure out things based on data that you're generating constantly, more so than to build a transactional application, like an e-commerce or something like that. It is to analyze data and do things based on that, whether that is informational or automation or personalization. There's a bunch of use cases for that. But one of our goals is that it's always fast. So it doesn't matter if you're starting with a few hundred records per minute or something like that, or thousands of records per second. This is designed to build up, and our key value prop is not just the scale, is the speed at which you can develop at any scale. So how quickly you can get to market with your solution. So that's the core of our focus is that combination.
Awesome. And so you're talking about, you mentioned speed of analytics queries as well. Can you give me a sense of hey, some of your large scale users, how many rows are we talking, and what's the query times for doing analytics over those rows?
Yeah. So we have customers that are ingesting 250,000 records per second, for instance. And based on that, they are building a bunch of different use cases, from a web application firewall that it's APIs that are analyzing the data that is coming in constantly to detect denial of service attacks and mitigate them automatically, to using that data also to build usage-based billing, or also to show it to your customers as user-facing or in-product analytics. So that's those are the sizes that we can manage, and more. That's just one customer. So obviously the aggregate of that is much more. And then we have on the other side, on the query side, up to thousands of requests per second as well, in terms of APIs that are exposed. And those have to be, very low latency, such that it can scale, because otherwise it becomes prohibitive. So we see latency, depending on the use case, but we see latencies of 30 milliseconds or 60 milliseconds and sometimes 200 milliseconds. But it really depends on your use case and what you're trying to optimize for.
Absolutely. And, we hear this, I think in the last couple of years, we've heard more and more people talking about real-time data, things like that. What does this mean, real-time? How real-time is this, especially for large aggregation type things? How behind is my data there?
This is really interesting, and this is something that we've been finding a lot in conversation since we started. A lot of people hear real time and immediately disconnect from the conversation because what does it really mean, real time? Where is the line that divides real time from not real time? But also because a lot of data teams are working with batch processes and have been doing that for many years. And a lot of people immediately say, "No, we don't need real time for a use case." The thing is that real time is so crazily better than not real time that once you start solving problems in real time, first, it's super sticky because you start thinking, wow, like I didn't even realize this was possible. And you start thinking, hey, what else can I do with real time? But also, it opens up, when you sort of reduce the order of magnitude of time that queries take, it opens up new ways of working, both from the point of view of development. It's not the same if your query takes a few milliseconds when you're developing than if it takes 30 seconds. Your experience of development is very different. But also from the operational point of view, if you can know exactly what's going on right now with your e-commerce or the marketing campaign you just put out, or the players in your games, whether they just hit a specific goal or something like that, and you can react to that automatically, it really changes the way that companies operate. And we've seen that repeated over and over, how they start thinking about their business in a different way, and it opens up new opportunities. So real time is not just, when we talk about real time, we talk about the combination of where the data is being generated and when it's being consumed. And we're talking about sub-second, couple of seconds there. That's enough to consider it real time and to enable all of those new ways of working.
I love that. I love that how, just really tightening that feedback loop, how it just changes behavior. It reminds me of like software release cycles and how that's changed. It's not a quarter release anymore. Exactly. You're just doing continuous integration, and how that it's not just speeding up, it's changing how you build stuff and iterate and all sorts of things.
Exactly. It's a new paradigm, and it's really difficult to explain until you actually use it. One of the beauties of Tinybird is, how, for instance, Kafka, it enables you to ingest data, and you have those topics that you can consume at different speeds by different consumers. So it's great in the sense that, you don't have to decide in advance what you're going to do with the data. So Tinybird works like that as well. Like, you can start ingesting in real time and solve one use case, but actually, because the data is there and writing a new use case is just one SQL query away, and then you activate an API endpoint, you can start consuming it. It drives a lot of usage. You can bring in other data to enrich it. So we've seen great expansion within our accounts because first, the real-time aspect of it, and also because it's so quick to develop and put new things in production that, becomes a sort of a no-brainer to do more things, So it's been beautiful to see.
Yep. Awesome. I love it. Okay. I want to dig into the architecture, the technical bits a little bit. I mean, first of all, like what's happening under the hood with Tinybird to like power these, performantly serve these huge OLAP queries? Like what's going on there?
Yeah. So we use Clickhouse as our OLAP database under the hood, and we take advantage of a lot of the sort of real-time capabilities of Clickhouse, and we contribute to them as well. But what we
can you tell me a second about like what is Clickhouse? Maybe just for people that aren't familiar.
Yeah, so Clickhouse is an open source database that came out of Yandex many years ago. They built it to basically do website analytics, to do Clickhouse, to manage to keep track of clicks and events and so on. It's great for OLAP loads, for time series, and for it's designed to scale horizontally and vertically as well. So it's really powerful. But we always say it's a bit like a Formula One, in the sense that if you have a team of specialists that have been doing this for a long time, and you have the Formula One driver, you can make the car run at 300 kilometers per hour. So what Tinybird is basically taking the best of Clickhouse and helping any driver, drive the Formula One, let's say.
Yeah, I love that. I remember when Clickhouse was kind of new and I was using Redshift at my job for something. I was like, oh, we wanted something a little faster, wanted to try it out. We tried it out. It was really fast. We're just like, there are so many moving parts and components here. And I don't know enough about tuning it to make it work. So awesome to see that as a hosted solution. How did you, I guess, sort of get involved in Clickhouse and figure out, hey, I want to start this company, Tinybird, that manages it?
Yeah, I should say here that I'm not the only founder. We're a 5 founder team, and we've been working together for a long time. We used to work at a company called Carto, which is in the location intelligence space. And at the time, they used Postgres, and we were struggling to meet the demands of our customers, who were coming with an order of magnitude more data every year, let's say. And we started thinking about how to solve that, how to cut through all of that, 1,000 times the data. And that's how we started investigating. Carto went in a different direction, more about, building on top of other databases rather than building their own sort of platform. And we started leaving, but finding the same problems in other companies is whenever there are huge amounts of data and you want to build something on top, people throw cathedrals of infrastructure at it. Also, there's been this whole conditioning going on about the modern data stack and, all tightly sort of divided up in verticals and components that VCs can invest in, but actually that doesn't lend itself great to real time. And, it comes with huge costs because every handoff you're paying, the toll, and basically, we wanted to do away with all of that. We wanted to work as developers, which is, hey, I love the idea of I have data, I write some SQL, and I can make something of it, So that's Tinybird in a nutshell. Yeah. It's the desire to essentially work with any amount of data the same way that we work with smallest amount of data.
Awesome. And I assume a lot of people listening are familiar with Postgres, MySQL, and just SQL generally and how it works. But like you're saying, when you get up into those orders of magnitude more scale, it doesn't work. So what is Clickhouse doing under the hood that gives it the same interface, SQL interface, but like under the hood, what is it doing differently than a traditional OLTP database?
I mean, the biggest difference is that it's a columnar database, and essentially that means that the data in the disk is stored per columns rather than per rows. So that makes a lot of sense for analytical queries, because if you want to add up, like, do a sum or sum of numbers, you don't have to go row by row to find all the specific columns. You basically read all those numbers in one go, and it is much, much faster. And then it's built for scale, like every single analytical function, like a sum or a count or a unique, they're all designed specifically to scale and, to work in such a way that also queries can be distributed across different nodes. So you can have, if you have 1 billion records and you have 4 nodes, you can divide the data into 250 million records in each machine, calculate that and then put it together. So that's what can help you scale to massive amounts of data. So the combination of those things and a bunch of other things here and there, but those are the main architectural designs, let's say, or approach that helps you do that.
Yeah, absolutely. That's great. And then, so based on that, we have a columnar rather than a row-based one. We also are splitting and trying to parallelize this work. Are there any like RDBMS patterns that people are used to using in OLTP databases, but then are inefficient, don't work in Clickhouse, need to change how that works?
Yeah, I mean, because the data is stored in columns, that means that things like updates or deletes are harder, because you need to find specifically each row in every part of the disk to get rid of it or to update it. So although it is possible to do, it's not it can't be done at scale the same way that you can do inserts or queries in Clickhouse. In Tinybird, we've solved that. We've added a sort of a layer on top of Clickhouse through the product that enables you to do large replacements and deletes, more from the point of view of mistakes are made often, like I've been ingesting the wrong data, I want to replace all of this data, and so that's very easy to do in Tinybird. And then from the point of view of designs and sort of the difference between RDBMS, things like that are trivial or part of the normal way of working, like doing upserts, for instance, or duplicating stuff, that's not trivial to do in Clickhouse. There are, depending on the use case, you might want to do different. It's possible, but you have to solve it at query time more often than not. It has some ways of doing it, but it doesn't guarantee the duplication. So we help a lot of our customers to find the right strategy depending on the right sort of on the volumes and the use case.
Cool. Also, I know like a lot of OLTP people, they're like, hey, if I need an access pattern that I want to make faster, I add an index, things like that. I mean, does Clickhouse Tinybird, does it have the notion of indexes and if so, why not?
It boils down to how you sort the data. There's a sorting key in Clickhouse that you can specify. That's really important when you have huge volumes, because, for instance, if you're building analytics for your users, you have a SaaS product, for instance, you're going to have a company ID or a customer ID, and then you're going to have some dates, and then you're going to have some events that you want to query. So if you sort it by company ID and by date, whenever you query, Clickhouse is going to find exactly, even if you have billions of rows, it will only read the rows that refer to those companies. So the way you sort the data can be important. And then that becomes especially important as you iterate. And that's why at Tinybird, we also invest a lot in helping users iterate, because it's not easy to iterate when you have billions of rows and data coming in all the time and queries happening against your table and so on. So being able to iterate on those as you learn what you need, it's really important as well.
Awesome. As I was looking at Tinybird, I saw this concept of pipes as I'm sort of getting data in. What are pipes? Why are they important? How do I use them? How's that work?
Yeah. So when we started Tinybird, it was the first iteration of it. It was have like a data, like a SQL editor, and that was it. The problem is, as things get complicated, you start getting queries that are like this big, and like really long queries that are hard to parse. That even for the people that have created them, the next time they come around, you need to sort of figure out what is this doing, kind of thing. So with pipes, it's a way to chain queries. So you can, for instance, let's say you first want to filter data. Well, you filter the data first in one of the nodes of the pipe. And then in the next node, you can query the results of the filter that you've done before and start aggregating. And then maybe you want to do, in a different node, you want to query some other data source and you want to join the result in a different node. So you can do joins between nodes, or you can do unions, and that these pipes are a bit like Jupyter notebooks, but in SQL. So you can comment as you go. You have a way to enter comments and to document what you're doing, which we found really helps with development and with bringing the rest of the team along to what you're doing and so on. So it's become a great way to develop and explore and work together in data projects.
Gotcha. Okay, so pipes they're a read time thing. They're not changing how I'm ingesting or like organizing the data differently on storage. It's all happening at read time going through those pipes.
Actually, I should have started there. Pipes, you can use them for different things. One of the things is creating API endpoints. So you can write a query, click a button, becomes an API that you can start integrating. But you can also use them to materialize data. So instead of saying, hey, the output of this query, I want it to be an API, what you do is the output of this query, I want to materialize into another data source or a data set that you can then query from a different pipe, for instance. So pipes are very flexible in that sense, and you can use them for these things. And we're working on other things like using the result of those pipes to send them somewhere else, not even to materialize, but to send them to a S3 bucket or a Kafka topic, or so as you're getting data, you can transform it and send it somewhere else as well.
Very cool. As I'm working with Clickhouse, and especially thinking about joins, does it make more sense to sort of do joins at read time, or should I be doing that beforehand, joining, denormalizing, having a wider table that can filter directly on that? Like what makes sense there?
We have a bunch of rules. There's a bit of a mindset you need to get when working with. So in general, if you want to scale queries, not just in Clickhouse but in columnar databases, but with Tinybird, we always sort of encourage our users to think in a particular way. One of them is first, if you're going to filter first, because apart from the sorting key we were talking about earlier, if you're not going to be using some data, just filter it out as soon as possible. Then if you're going to do joins, join as late as you can. So if you can filter out the data, then do your aggregation and then join, then it's going to be much faster than if you join first and then aggregate, because you will be doing it with a smaller amount of data. So it's not so much that you can't do joins, you can do joins, no problem. Is how do you make them fast? And there's a bunch of rules that we are first educating our users on, but also bringing into the product in terms of paradigms and guidelines that you should follow to make your APIs fast, basically.
Yeah, interesting. Do you have like query planner type statistics or different things where I can see, hey, I ran this query and like you're saying, maybe I'm using a join inefficiently. How can I debug that, or what does that look like for a user?
Yeah. We've invested a lot in providing observability on top of what you're doing. So in the very same pipe, when you run a query, you can see how much data you're scanning, how long did it take, how many cores did it use, to see if it's being distributed or not. And then you can also, once you publish your APIs, by the way, all of the exploration queries in Tinybird are free. So if we're not going to charge you for while you're developing, let's say. So in the pipes, all of that's free. But when you expose an API and then you start using it, you're going to want to know how much data am I processing, how fast is this going, how many requests do I have. So all of that data, in real time, we dump it back into your account so you can query it with pipes. So in the same way you query your own data, you can query the data that your account is producing. So it's very meta, like everything you produce, we enable it for you to query as well. And people are doing amazing stuff. Like, for instance, they're building APIs over those data sources and then integrating with Datadog to monitor their usage or to monitor performance and things like that. So it's become super, like the observability layer. It's a very important part of our product.
Awesome. I love it. I think it's so interesting to learn more about like columnar databases and how they're different than the row-based stuff and how it really twists your mind. Like, a bunch of things you mentioned. One other thing that always stands out to me, if you have like a sharded database, whether that's a NoSQL one or even like Vides or something like that, often you want to try and hit exactly one shard, find the exact item you want and pull that record back. But like you're saying, Clickhouse is also sharding, but you sort of want to use up those, like make sure each shard is doing a fourth of the work if you have 4 nodes, like you were saying, easier. So just like some of the paradigm shifts moving between OLTP, OLAP is interesting. And I think educational work is just such a big part of what you all have to do and just teaching people how to use those things.
Yeah, and it's a deep topic. It's fractal. The more you learn, the more you realize there's more to learn. But at the same time, there's a set of guidelines again that once you sort of master and you start thinking like that, you get really good performance. At least with Tinybird, I can't judge for other products, but you get really good performance out of the gate. And then when, for for bigger accounts and so on, we have we have different plans, but we have for big accounts we also enable a sort of services, as in we call it Premier Support, which is essentially there's a named data engineer you can talk to in Slack that basically knows your use case, but also knows the product inside out. Because we want to ensure that you can, we never want someone to be annoyed because they're paying too much because their queries are consuming, consuming the wrong data. It doesn't make a difference when you're dealing with small amounts of data. It won't move the needle. But if you have billions of rows, you're going to want to optimize and so on. And then now we're also doing something we call the Jumpstart package, which is for people that just want to try. And basically it comes with a data engineer as well to help you get to production. And then you can stay on that package or move on to other packages as long as you want. Because I think there's people that sort of, because they don't control the medium, just having someone that says, hey, look, try this, start with this starter kit, or, it really helps a lot and gives people a lot of confidence.
Yep, I love it. On that same note, you're talking about packages, plans. Like, what does pricing look like for Tinybird? Is it usage based? Is it monthly, or how does that work?
Yeah, there's a free plan. You can start on a free plan, and it includes 1,000 requests a day. So as long as if you build something small and you want to, for personal use and things like that, very rare that you'll hit more than 1,000 requests a day. And then if you want to remove the limits, basically you put your credit card in, and then we charge by two levers. Let's say one is process data, which means how much data you're scanning or writing, and also storage. Although storage is something that over time it normally is the smaller part of the bill, let's say. But we're sort of working towards trying to remove that entirely to make it storage as cheap as possible, so that you only have to think about what is it you're building, how much you're using the system, really.
Yeah, and in terms of architecture, I mean, is this is it like a multi-tenant system that you're running? Are people running on shared machines, or if someone provisions a new instance of Tinybird, you're going to set up 4 nodes somewhere for them, and they're just for them? What's that look like?
So we have multi-tenant infrastructure out of the gate. So if you sign up, you're in multi-tenant infrastructure. But then for bigger deals, let's say, or sort of a enterprise deals, then we have a lot of dedicated infrastructure provisioned. But it is completely transparent to you, as in you don't have to do anything. You basically, as part of becoming one of those customers, you go into dedicated infrastructure, and then you're only sharing, let's say, the first the front end, let's say, and then everything else it's your database resources, and such that that you don't have noisy neighbors or anything like that.
Yeah, absolutely. Well, as a developer, I love the trend towards more like fully managed databases and stuff, and it's great. And you've been doing this now at a couple companies, both Carto and here. What's hard about running a managed database solution? Under the hood, like what are the difficult parts that you've sort of learned?
Yeah, I think there's sort of the first two things that come to mind are, first, that when you put a platform out there with a set of APIs and a database and tell people, hey, use it however you want, people do the craziest things, so, and use it in ways that you didn't even imagine, it could be used. So that generates a lot of tension, because suddenly, you had designed your architecture thinking of certain use cases, and suddenly you're hitting limits and problems that you hadn't sort of designed for. And that's a constant that happened sort of the first day we had a customer, and continues to happen to this day, because the more customers you have, the more things they'll try to do, and the more pressure it'll bring to bear, let's say. So that's something you sort of have to manage, and sort of start to put rails for people to try to go through without losing the flexibility that we want to provide. So put certain limits in certain type of operations to ensure that things remain within reason and so on. The other part also is like there's a part of the market that is, as you were saying, like you're excited about things becoming fully managed and serverless and so on. And we see a big trend in that direction. But some companies, and for policy reasons and for, they want to have it sort of hosted and so on. And so that's things we also, from a go-to-market point of view, we come across. And but anyway, it's all part of. It's not that we didn't expect this, but we knew it from Carto, the same problems. But that is something you have to also think through, and what's your strategy there, and so on. So those are the things that come to mind.
Yep, awesome. We talked about a lot about ingesting data, querying data, things like that. Where does the data come from? Like, how do people get data into you? I imagine they're just not hitting it an API one by one with 250,000 rows a second. So how do they get that data to?
You'd be surprised, but well, for streaming data, we used to the way we started was with CSVs. We had an API when you would send a CSV. That was like 3 years ago. And the reason we did that is because CSV is the universal currency for databases. Any database can produce a CSV and so on. So we thought, well, it's always going to be a good default. But very soon we saw that the push was towards streaming, and we built a Kafka connector. That Kafka connector is through which we receive our biggest loads at the moment. But also we found that there are people that don't want to go through the hassle of either hosting Kafka or have the added expense of hosting the Kafka somewhere else. So we built a streaming endpoint. We call it the Events API. And essentially, it's an endpoint that you can send one or more NDJSON objects in every request. So you can send maybe 2,000 requests, 2,000 objects every request, or one every request, however your use case is. And we ingest that with very high frequency at an amazing scale. And that a lot of our users are using that, interestingly, because even if sometimes they're using Kafka or Kinesis, actually it solves a lot of problems. It simplifies setups a lot. It's just a trivial post to us, and that's really it. So that's another great way. And then we have connectors to other data warehouses like BigQuery or Snowflake and so on. And those are more to bring dimensional data. So because customers already have data sitting in databases like a products table or customer plans or whatever. And then with those connectors, we just keep the data synchronized so that you can do joins and you can enrich in real time when you ingest and things like that.
Yeah, very cool. What about ingesting, like tailing from OLTP sources, whether it's the MySQL replication log or DynamoDB streams or something like that? Is that something y'all are looking at, or what's that look like?
Yeah, we did our own first implementation of a CDC connector as well, but it's working for a couple of customers, but we're not going to continue that. We're going to, for CDC approach, we're going with what's the name?
Debezium, that one.
Debezium, thank you.
Okay. Yeah. Okay.
Yes, I wasn't. I suddenly slipped my mind because it's battle tested already. It can go through Kafka. It can, we can do sort of different approaches there. The problem with CDC and scaling CDC is not so much connected. That's just the bin log problem. Let's say it's solved. Debezium does it really well, and others. The problem is because the data that you're getting from bin log is not just inserts, it's also updates and so on, deletes. Is how do you deal with that in the OLAP side? And so it's very easy to, if you have an append-only table, super easy to replicate and set up. It's harder if you have updates and so on, and you want to keep like an always up-to-date version of the data. And that's something that we're working on to facilitate as well, so that it's transparent and so on. We do it now following some like sort of micro batching and sort of materializing in batches and so on. So we can solve the problem right now, but it's not ideal. And that's something we're working as well towards trying to solve in a more transparent way, because it's, I mean, if you think about it, who wouldn't want that? You know, it's like connecting to having a sort of scalable replica for analytical queries of whatever you're doing in your database. Yeah. And then, but we also use tailors for other things like logs and things like that. We have a bunch of use cases building real-time analytics over logs. We have a tailor that we open source called TVTail that you can connect to any log and just send to our events API, so that you can build a web application firewall or charts over your logs and so on, and connect it to other data sources and things like that. So pretty useful as well.
Yep. Very cool. I love it. Okay. I want to close off with just a little bit about the company, the future, things like that. So tell me about Tinybird. Like how long have you all been around? How big is the company? Where are you all based? What's that look like?
Yeah. So we officially started sort of by mid 2019. So 3 years ago. And we, we're now almost 60 people. We've raised a bunch of money. You can sort of with CRV and Crane and Singular, and which amazing investors have been great to us. And we are now we're a US based company. We're all Spanish founders, but the headquarters are in the US, and the company is growing a lot here. I'm living in the US now. That's where we're at, and we're seeing huge opportunities and huge interest in sort of real time data storage and processing and so on, and we're here to capture all of that as much as we can.
Yeah, well, in 3 years, y'all have some good logos on the site, and that's a lot of just like core infrastructure that you need to build up before you can even start taking on users. So y'all have done a great job there. Last thing I want to ask, just like what future improvements, like what any like target areas you're looking at, or features or different things? What's on your roadmap?
Yeah, so there's a bunch of things. One, obviously, one of them is we want to be completely cloud agnostic, and we started in one cloud, which is Google Cloud, and now we're very soon we'll announce another cloud, and we basically want to go for all of them. Because people have very strong requirements about that. Like they want to be in one cloud or other. They don't want to be paying egress costs, moving data around, things like that. That makes complete sense. And we don't really care. We want to be where our customers are. We also, lowering the barrier of entry and making sort of connectors to pretty much anything that people use is also really interesting to us, because again, the experience that we want to provide is that you can build an API literally in a couple of minutes, and that part of that is saying, okay, my data is here. How do I expose it here? So we're investing in that a lot. And then another constant source of improvements for us is in the iteration of and how you build data products as a team with tests, and in the same way that you build software development projects anywhere. And it, if you think as a something like Rails, for instance, like Rails has migrations. When you want to put something in production, there's a way to do those things. With analytical data is not as straightforward, because, maybe a Rails application database is, 1 gigabyte and I'm pushing very high, but analytical databases can be terabytes of data or more, So when you want to make changes, it's not as simple as, hey, I'm just going to run a query that is going to turn this column into something else. It can be very complex. So we're investing a lot in making that trivial, safe, and easy. So that's a big technical challenge. And we're obviously hiring. So anyone hearing this, we're always hiring.
Awesome. Well, I'm glad that you're solving these problems so that I don't have to. I can just use the cool stuff. And I really appreciate you coming on and teaching us, how Clickhouse and Tinybird are, thinking about columnar databases and parallel databases as compared to OLTP stores. I think this was really useful to a lot of people. So, Jorge, thanks for coming on, talking about Tinybird, and best of luck to y'all going forward.
Of course. Thank you for having me, Alex.
Yep. See ya.